This presentation explores wastewater treatment and is presented by Joyce and Michael Vissaritis.
Wastewater is the water you've used in your homes, schools, businesses, and industries. About 70% of Greater Sydney's wastewater is made inside the home. It goes down drains from sinks, baths, showers, laundries, and toilets, and other drains inside buildings. It's 99% water, with the remaining 1% being made up of things you've added to the water. Wastewater also includes storm runoff as harmful substances wash off the roads, parking lots, and rooftops.
If wastewater is not properly treated, then the environment and human health can be negatively impacted. These impacts can include harm to fish and wildlife populations, oxygen depletion, algal blooms, beach closures and other restrictions on recreational water use, and contamination of drinking water.
The stages of water treatment.
Primary treatment aims to remove large and settleable solids from wastewater, as well as to reduce the load of organic and inorganic materials that could interfere with subsequent treatment processes. This phase serves as the first line of defense in wastewater treatment. Primary treatment focuses on physical separation methods to achieve these goals, including screening, comminution, and sedimentation.
Screening occurs at the beginning of the wastewater treatment process. It involves water passing through various screens that retain large solids like paper, plastic, rags, and metals. This process leverages the physical principle of size to effectively separate and remove debris from the flow. It must happen early in the process, as large objects could damage downstream equipment like pipes and pumps.
Comminution is a critical physical process in wastewater treatment that involves the mechanical reduction of large solid particles into smaller fragments. Grinders or shredders break large solids, such as pieces of plastic, into more uniform pieces.
Sedimentation is a pivotal physical process in the early stages of wastewater treatment. During this phase, wastewater is allowed to flow slowly through large tanks called sedimentation tanks. Particles denser than water sink, while particles less dense than water rise, such as grease and oils, where they can be skimmed off. The accumulated solids or sludge form at the bottom of the sedimentation tank and are removed periodically. Secondary treatment focuses on biological and chemical processes. This typically involves the removal of dissolved and suspended organic matter using microbial communities. The goal is to produce cleaner water that is safer to discharge into the environment or for further treatment. Billions of microorganisms are added to the wastewater to break down nutrients present in the water. These nutrients come from soaps, detergents, human waste, and fertilizers. This step in the treatment process prevents excessive plant growth and then eutrophication. These nutrients, particularly nitrogen in the form of nitrates, nitrites, and ammonia, if left in the water, can fuel overgrowth of weeds and algae, causing algal blooms which deplete oxygen, consequently killing animals.
Removal of nutrients. The nitrogen-based nutrients are removed through aerobic and anoxic processes. The ammonium in wastewater is converted to nitrates via the aerobic process of nitrification, seen in the equations for different bacteria below. An anoxic environment is then applied to enable denitrification, the removal of nitrate by forming nitrogen gas. Facultative bacteria are forced to use the oxygen from nitrate for their metabolic processes as there is no free oxygen, resulting in the release of nitrogen gas. Phosphate is removed by phosphate accumulating organisms, POAs, in a similar two-step process. Under anaerobic conditions, POAs initially release phosphorus to the wastewater and activated sludge mixture, mixed liquor. This is achieved through the addition of volatile fatty acids, VFAs, that are consumed by the POAs, resulting in release of phosphate to the mixed liquor. In the aerobic phase, a much greater volume of POAs are added, allowing for absorption of phosphorus from the mixed liquor. This nutrient is now part of the bacterial cell and removed as sludge in the clarifier. If these nutrients are not removed, equipment in water recycling plants, such as reverse osmosis membranes, can be adversely affected. This can reduce the efficiency of the entire treatment process.
Tertiary treatment is the final stage in the wastewater treatment process. Tertiary treatment can achieve levels of water purification that can make the water safe for reuse in water-intensive processes or even as drinking water. The process usually involves filtration followed by additional disinfecting treatment to remove harmful microbacterial agents.
Wastewater treatment plants can add chlorine to the wastewater to eliminate harmful microorganisms such as bacteria and viruses. However, chlorine can negatively impact aquatic ecosystems, necessitating dechlorination of the treated water before it is released into the environment.
UV light is another common disinfectant used in tertiary treatment. Wastewater is exposed to UV light, which sterilizes microorganisms by damaging their genetic material, rendering them incapable of infecting humans or wildlife.
Ozone, a compound created by adding a third oxygen atom to diatomic O2 using electricity, is another disinfection method. Ozone is highly reactive and can destroy most microorganisms it encounters.
After wastewater treatment, the treated water is often discharged into local water bodies, reused for irrigation, industrial processes in homes and businesses, or even further purified into drinking water in some areas. The solids or sludge are typically processed further. They may be used as fertilizers, composted, incinerated for energy, or disposed of in landfills. The aim is to recycle and recover resources while protecting public health and the environment.
This is our reference list, and thank you for listening.